Welcome to the course of fluid mechanics. In this session, we are going to discuss about the fluid pressure, Pascal law, and hydrostatic law. So, we are starting with the fluid pressure. What is this pressure? Fluid pressure. This fluid pressure is also called the, in this slide you can see here, the fluid pressure is also called the intensity of pressure. Both are the same. Pressure or intensity of pressure. What is this? Pressure at a point is defined as the ratio of force to area. Pressure is equal to force to area. This is called pressure. And this force acting perpendicular on the area of the fluid surface at that point. So this is the pressure or fluid pressure or intensity of pressure. So what are the different units of pressure? Unit of pressure are Newton per meter square, SI unit. It is also called the Pascal. Pascal is the other unit of the pressure. kgf per meter square is the another unit of pressure. Other is the bar. That is the Newton per meter square, Pascal, kgf per meter square, and bar. And the relation between these units are 1 Newton per meter square equal to 1 Pascal. That is the conversion from Newton per meter square to Pascal or Pascal to Newton per meter square. 1 bar equal to 100 kilopascal. 1 kilopascal equal to 1000 Pascal and 1 kgf equal to 9.81 Newton. This is the conversion of the units from one to another. This is about the fluid pressure. Now we are coming to the next slide. This is the Pascal law. What is Pascal law? Pascal law, it states that the pressure or intensity of pressure, that is the pressure at a point in a static fluid, is equal in all direction. If the fluid is static, that is no flow in the fluid. So pressure at a point is equal in all direction. That is pressure at x in x direction px, pressure in y direction is py, and pressure in z direction is pz. So all px equal to py equal to pz. That is px equal to py equal to pz at a point. So this above equation states that the pressure at any point in x, y, and z direction is equal. This is the Pascal law. Hope so it is clear. Pascal law, it states that pressure at a point is equal in all direction if the fluid is static. This is the Pascal law. Now coming to the hydrostatic law. So hydrostatic law deals with the pressure variation. It deals with the pressure variation in fluid at rest. When the fluid at rest, then what is the variation of pressure in the fluid in the vertical direction? That is governed by the hydrostatic law. What is a state? Hydrostatic law states that the rate of increase of pressure in a vertical direction, the rate of increase of pressure in vertical direction is equal to the weight density of the fluid at that point. The rate of increase of pressure in vertical direction is equal to weight density of the fluid at that point. So this is, in the terms of equation, it can be written as d over p upon d over z. P is the pressure, z is the vertical direction distance in vertical direction. So d over p upon d over z, this is the rate of change of pressure in vertical direction, and this should be equal to weight density, and weight density is equal to rho into g. Rho into g is called the weight density. So this d over p upon d over z equal to rho into g. If you integrate both sides, then you will get p equal to rho gz, where p is the pressure, rho is the density of fluid, g is the acceleration due to gravity, and z is the pressure head. That is the height in the z direction. So p equal to rho gz. This is the hydrostatic law. This comes from the hydrostatic law. So this pressure is varying with the z pressure head. This P, that is pressure at a point, is varying with the Z. If the liquid is if the liquid is incompressible, then the density is constant and G is also constant. So in that case, only in case of incompressible fluid, pressure at a point is vary with the Z, vertical height only. This is the hydrostatic law. Better if you solve a problem, you can understand this in a better way. Before going to solve a problem, I would like to uh, give some diagram here. I'm using this annotation. So this is your, suppose uh, if there is a static fluid, suppose it's a static fluid. So this is your reference bottom line, and this is your distance. This distance from reference line, that it may be Z1. So this is your Z1, and this distance, suppose this is your Z2. So at this point pressure, that is at this point on this line, the pressure at all points is equal as per the Pascal law. And what is the pressure? It is governed by the hydrostatic law. That's P equal to, at this point pressure, suppose P1, that is equal to rho, density of this fluid rho, G, acceleration due to gravity, multiplied by Z1. Z1 is the distance, that is the pressure head. So at this point, corresponding to this point, if we go, then the pressure P2 equal to rho G is Z2. So at all points at this line, pressure is equal because of this Pascal law, and this pressure is governed by the hydrostatic law. How to compute this one? So now coming to the problem 1. See, this is the numerical problem. A hydrostatic press has a ram of 30 centimeter diameter and a plunger of 4.5 centimeter diameter. Find the weight lifted by the hydraulic press when the force applied at the plunger is 500 Newton. Oh, hydraulic press, this is a ram. Well, you see, this is your ram, and it has a diameter of 30 centimeter. Diameter is given for the ram is 30 centimeter, and plunger has a diameter of 4.5 centimeter. This is plunger, it has a diameter, suppose this D2 is the diameter, that is equal to 4.5 centimeter is given. This is the diameter of this plunger, centimeter. Now for this ram, diameter is, suppose this is your D1, it is given 30 centimeter, right? This is 30 centimeter, this is 4.5 centimeter. Now what we have to find? Find the weight lifted by the hydraulic press. This is the press. So when the force applied at the plunger is 500 Newton. So this is plunger and the force applied is F, that is equal to 500 Newton. This force is equal to 500 Newton. When the 500 Newton force is applied on this plunger, then what the weight this press will lift? Suppose this weight is W. We assume this weight is W. This weight is W. We assume this weight is W. So what is the value of this W? That is the weight. What is the value of this weight? If we apply the force F equal to 500 Newton on this plunger. See, the fluid is in the static, so whatever you force applied here at this, both are at the same line, that is this line will be equal to on this line, that is this line is this line, same line. So whatever force applied on this plunger, the same force will be transmitted here in this ram. On this ram, the same pressure is transmitted here due to Pascal law. Due to Pascal law, the pressure at this point should be equal to pressure at this point on the same line. So pressure At this point, at the plunger point, what is the pressure P1? Pressure equal to force upon area. Force is given 500 Newton, F upon area, A1. A1 area can be determined by A1 equal to pi by 4 D1 square. Suppose this section is D2, so write is better this D2, this is P2. Now this ramp section is P1. So this P1 equal to force upon area, and force is nothing but the weight. So W upon area. Area is here is the A1. A1 equal to pi by 4 D1 square. So D1 is given 30 centimeter. Here D2 is given 4.5 centimeter. F is also given. So we have to apply the Pascal law. As per the Pascal law, P1 equal to P2. This P1 equal to P2. And in P1 component is your W upon A1. W upon A1, this is P1 component. And P2 component is your F upon A2. F upon A2. So here A1 is known, A2 is known, F is known, only W is unknown. So you can compute the value of W from this Pascal law equation. Here A1, how to compute A1? A1 is equal to pi by 4 D1 square. Pi by 4 D1 square. So value of D1 is given. D1, that means for this ramp diameter is given 30 centimeter. D1 is 30 centimeter, that is 0.3 meter. Similarly, A2 we can compute. A2 equal to pi by 4 D2 square. And D2 equal to 4.5 centimeter, convert this into the meter. So 0.045 meter D2. So in this way you can compute A1, A2, F is already given 500 Newton. So W you can compute easily. The W comes the weight in Newton. So in this way, using the Pascal law, we can solve this numerical problem. So thank you.